Today we're going to be talking about the k-means algorithm. So the algorithm starts by making different blobs of data. So these data is going to have it's going to be centered around 4 different areas with a standard deviation away from that center of 0.6, and we're going to have a random sample of 300, and we have a random state of 0. So we're going to have our function for our Euclidean distance, which we're going to be using to determine the distance between the points of each point to each centroid, and for the calculation of the convergence parameter. And here we have our function which initializates our centroids, and we have a random seed, so this makes it so that we always have the same centroids, and we have a random permutation from which we're only going to take the first k elements so that we can get a random point from our data to act as our initial centroids. So this is the k-means algorithm. As we already saw, the first thing that it does is that it initializes the centroids. And here we can see the initial centroids that we had. So then we add the original centroids to the centroid history so that we can see how the centroids changed throughout each iteration. And then we assign clusters. We begin a loop in which we assign the clusters to each of our points. So if we go to the function of assign clusters, here we can see that we first calculate the Euclidean distance of the point to each of the centroids, and then we get to which centroid it belongs to by using the argmin of the distance. So this will give us the centroid with the minimum distance, and by doing this, by appending it, we are creating an array which will give us to which centroid does each point of our data belong to. Then from there, we pass the clusters into our calculate new centroids. And our calculate new centroids, what it's basically going to do is that it's going to be calculating the mean for each of the points belonging to a centroid, and it's going to be calculating for each centroid and for each of the attributes that our data has, because our data can be multi-dimensional. So that's why here we're looping for L in the shape of the amount of attributes that our data has. So with that, we can then we can get our new centroids, and we can begin to calculate the distance between the current centroids and the previous centroids. So we do this by calculating the Euclidean distance and squaring it, and it has to be less than or equal to epsilon in order for it to converge. And by doing this, instead of doing the 100 iterations that we have by default, we can see that we stopped at the 4th iteration as we don't have any significant changes. From here, I took the time to plot the centroid history. So here we can see how the centroids behaved throughout the 4 iterations, and we can change where the centroid starts by changing a random seed, and by changing a random state we can change the data. So if we execute this, we're going to have a different result. As you can see here, we have different initial centroids, and here we can see that the data behaves differently as well.